Kiran, good morning.
Hi there. Very good morning. How are you?
I'm good. How are you?
Yeah, I'm good. I'm good. Just waiting orders to join. Okay, I think let's get started. And
Okay, sure.
yeah,
So let me share my screen.
yeah,
Yeah, just make me co-host.
yeah, yeah. Just- Okay, you can do it.
Okay, so today we are going to start with the core concept of Hyperledger Fabric.
Mm-hmm.
So here, these are the topics. Initially, this is the first part of the core concept, and these are the topics which we are going to discuss. So the very first thing is we'll try to discuss the reference architecture. Okay, so
Mm-hmm.
how the different components are there, what is the use of those components, and how they connect with each other. So that reference architecture we are going to discuss. After that, we'll discuss some core features of Fabric, what kind of features of Fabric is providing for the enterprise blockchain. After that, we'll discuss some network component, what kind of components are there. uh, like using that component, we can build a Hyperledger Fabric network. Then we'll come to the concept of channel. So complete channel, how, what is the channel, how channel is being used, and how we can create the channel. So those we are going to discuss. And then MSP, that is membership service provider. So along with MSP, we'll discuss the identity first. What is an identity? How to generate an identity, and then how to generate the MSP and identity and MSP, how they work parallelly. So that we will discuss. Then we'll come to the ledger part. So how the ledger is there and how it is different from Bitcoin or Ethereum. So that ledger we are going to discuss for Ethereum, for HLF, and then smart contract and chain code, and then transactions. So these are the topics which we are going to discuss in this particular session. So moving on, so the very first thing is, what is Hyperledger Fabric? Okay, so Hyperledger, yesterday we have seen, that is a foundation. That foundation has created one or developed one solution that for enterprise blockchain, which is a fully permissioned and which has the full privacy levels. So to keep in mind like that, with that features, they have developed a framework for the enterprise applications. So that framework we call the Hyperledger Fabric. Now, when the Hyperledger Fabric was designed initially, so it was like, it was not like just what we see today. Okay, so it was like in 0.6 version. That was the very first version of Hyperledger Fabric. So in that version, there were no channels, there were no other concept, only basic network they have created, and then day by day they have upgraded to the system. So right now the framework which we see, that is a kind of LTS version, or most advanced version right now we see. Okay, and it is a modular and versatile design. Okay, modular and versatile design meaning it is not like if the framework is there, you cannot modify something, or if you want to customize the framework, you can customize all the components of the framework. Okay, let's say there is a concept of consensus mechanism, right? In the Bitcoin or in the Ethereum. In the Bitcoin, we use proof of work. In Ethereum, we use proof of stake, right?
Yeah.
And that you cannot change, correct? Because that is the inbuilt consensus algorithm, and you have to use that consensus algorithm only. But in the Fabric, they provide a modular architecture where you can change your consensus algorithm. Okay, it is your choice which consensus algorithm you want to use. Okay, so there is a default consensus algorithm that is Raft, and earlier we had Kafka and Solo also, but right now only Raft consensus algorithm is there. But if you want to plug in any other consensus algorithm which you feel like you can develop, and that is your requirement, so that can be that can be plug in, and then you can do your transition with that consensus algorithm. So that kind of features it has, which makes this platform or this framework as a unique as well as the modular. Okay, so those features we are going to discuss next, where we'll discuss about the core features. But before that, let's check out the reference architecture. So if you see the reference architecture here, basically here mostly four services, four layers you will find. Okay, one is API and SDK and CLIs. Then we have the blockchain services, then event services, and complete set of services which provides chain code service plus membership services. Okay, so basically three services are there which are part of your main network, and those services can be called from the API, SDK, and CLI. Okay, so I will explain you one by one. So the very first thing in the private blockchain, especially if you want to be part of the network. Okay, so what is the very first thing you would need is you would need the identity, correct? So that identity comes very first, and that identity comes in the membership. So basically the membership service will provide you the identity as well as the registration, enrollment. So basically all kind of authorization, authentication, these kind of services will be provided by the membership. Okay, so whenever a new user join, so he will require certificates, digital certificates, his public private keys. So those keys will be generated by the membership services. So that membership services is not actually part of your network. Okay, so they because what happens is membership service you can use the third party membership services also, right? So in the membership services, basically a certificate authority will be there. So what is a certificate authority? Certificate authority is a organization or a application which issue these certificates. Okay, so let's say very simple example if I give you here. So let's say let me open one URL here. Let's say I just open www.icloud.com. Okay, so on the icloud.com, if you see here, one icon is available, right?
Yeah.
This is one icon. So what this icon is saying is, let me open this. Safari is using encrypted connection to www.icloud.com. Okay, and when we use the encryption, that means that this particular website is using the certificate, digital certificates. So you can see here, encryption with a digital certificate keeps information private as it's sent to or from the website, correct? And
Right.
now if I show the certificate, okay, so here this is the certificate details you will find here, and which is issued by Apple Public EV Server RSA, and it got issued to the icloud.com, right? So the Apple service EV, right? This is the certificate authority. Okay, So this is a third party services authority. Okay, this is one company actually, and which comes under DigiCert High Assurance EV Route CA. So these are these two are the DigiCert and Apple Public. These are the certificate authority who issue these certificates. Okay, so in Fabric you can integrate this third party services certificate authority also, as well as we have the provision to create our own certificate authority. Okay, that we call it as a Fabric CA, Fabric Certificate Authority. Okay, so now coming back to the membership.
If we create a certificate authority with Fabric, those certificates will be applicable specific to that particular network, right? We cannot issue those certificates outside the network.
Yes, yes. So mostly it is designed in such a way that it can help you out your network, only your network. So basically what we do is we create the certificate authority based on the organization. So let's say you can have single certificate authority also for entire network, or you can have certificate authority your organization wise. So let's say for org1 one certificate authority, for org2 another certificate authority, like this. So that is the case here. So now I hope you understand the importance of certificates and the certificate authority, and all this comes under the membership services. And since we can use the third party service certificate authority also here, that is why membership is not actually part of the blockchain services. Okay, it is outside the network. So that is the main concept here. Okay, so whenever we are going to discuss about the complete network, so you will always see membership services are the optional one, or the like it is excluded from the network. Right now, second thing is the blockchain services. In the blockchain services, blockchain plus transaction, these two things will be coming. Okay, now in the blockchain services, the very first thing will come is consensus manager. Okay, so what is this consensus manager? Consensus manager will be responsible for transactions. Okay, so how you get the consensus for a particular transaction, that will be managed by your consensus manager. Okay, so in the Hyperledger Fabric, what happens is whenever you or any blockchain, right, transactions are like it is not a straightforward update or straightforward create a record in the database, right? It is not like that. So in the blockchains, if you want to do any kind of transaction, so the very first thing is you have to have the consensus in place, right? So in the Bitcoin, you have seen mining process where we achieve the consensus. In Ethereum also you see the mining process where people put stake and then they create the block and all. So that concept comes here also, and that concept works, or that concept comes inside the consensus manager. So consensus manager is the something which will take care of the block creation and the transition process. Okay, so whenever transition comes, so that transaction will go for the endorsing process. There is a one term or one process that we call as an endorsement process. So endorsement process plus block creation. Okay, so one thing to remember here is your endorsement process will be taken care by the endorsing peers. Later on we'll understand what is the endorsing peer. For now, just keep in mind, when you combine the endorsing process plus the ordering process. So I'm telling you two keywords here, okay, or two main keywords or main concepts here: endorsing process and ordering process. So endorsing process will be always done by the endorsing peers, especially peers. Okay, and the ordering process will be done by orderer. Okay, so in the network we will be having two types of nodes. One is peers, second one is orderer. Okay, so you can visualize, or you can just compare with the Ethereum or the Bitcoin. In Ethereum, you have normal nodes and you have mining nodes, right? So consider the normal nodes as a peer here, and your mining nodes who actually create the blocks, right? Or who take parts takes part uh, in the mining process. So that we call as a mining nodes, right? So here we call it them as a ordering service or ordering nodes. Okay. So when we combine these two processes, our complete consensus manager will be there. Okay. Next, we have the distributed ledger. So whatever type of ledger you have. Okay. So as you know, like in the Hyperledger Fabric, the ledger which we are going to have, that ledger is a distributed ledger. Okay, because it will be like multiple copies will be there, like a single database, but multiple copies will be available to multiple nodes. Okay, so that is the distributed ledger which comes under the blockchain services. Then P2P protocol. So P2P protocol meaning peer-to-peer connections. Okay, it is not like any centralized database or a centralized server is there who is managing the connections. Here, all the peers, all the orders will connect to each other. Okay, so direct connection will be there. Then ledger storage. So whenever you create any ledger, of course, that is a database. The database requires some storage. So for that, the storage is also available with the blockchain services. So these four components you will find in the blockchain services. Okay. Now, any questions here on the blockchain services?
No.
For now, just keep in mind like the terminology which I'm using right now.
Yes. Yes.
Okay,
Yes.
that terminology, that keywords will discuss in detail with the individual topics. Okay. So now the third thing is the third part is the chain code services. Okay. So with the blockchain services, we'll create the network. Our transaction will go here and there. But when we talk about the logical things, right? When we talk about the logic, application logic, so for that we write the chain code. And here in the Hyperledger Fabric, chain code will run as a separate services. Okay, so it will run as a separate service, even though it will be mapped. It will be inside the network only, but it will run as a separate service. Okay, so separate service meaning. So the very first concept which you have to understand here is your chain code will be deployed on the peers. Okay, not on the orders. Okay, so chain code can be only deployed on the peers. So peer nodes, we can deploy the chain codes, and whenever a chain code is deployed, that chain code will be running in a separate container. Okay, so now separate container meaning separate machine. You can for now, like until unless we I explain you Docker and Docker containers.
Yeah.
So for now, you can really, it will be running in a separate machine. Okay, so your peer will be running, peer node will be running in a separate container, and your chain code will be running in a separate container. But those two will be mapped to each other. Okay, let's say I have created one container for one peer, that peer 0, and for peer 0 I have a chain code also. So that chain code will be running on a separate container, but this peer 0 container and the chain code container both will be mapped. Okay, so this is how we map the different containers. And while when we map the different containers, of course we are going to create multi-container application, like multiple systems are running in the parallel. So that is why the Docker will help us here, and Docker will create a network for us, that is Docker network, and all containers will be attached to that network. Okay, so now here the main thing to remember, or main thing to understand here is your chain code services. So chain code service will always run in a separate container, that will be secure container. And whenever you try to change anything in the chain code services, that time you have to get the approval from all the organization. So that is how it is highly secure. Like no one can tamper any chain code functions in that way. Okay, so that is our chain code service. Now all these three services will be running on event stream. Okay, so event stream is like a networking protocol where wherever any event happen. Okay, So then every service will get to know about that event, and accordingly they can act on that particular event. Okay. Now the main thing comes here is, this is our network part, right? Blockchain services, chain code services, as well as the membership services at some extent. These are our network things. But the question, the big question here is how your because when you create the end-to-end application, you will be having a front-end application, right? Maybe a progressive web app, or maybe a mobile application, Android application, or iOS application, right? Because your customer or your user will be will have that application as a client, right? So how that client will interact with this network, right? Because we have to have the connection, create the connection, because this is just a backend in the net, like network is just a backend, right? So for that we have three options. Okay, basically to interact with the blockchain network or to interact with the Hyperledger Fabric network, we have three options. One is we can interact with the APIs, SDKs, or CLI. Okay, that will come here. These are the three things. So APIs meaning you can write the APIs, and with the APIs you can interact with the, let's say I want to do a transaction, so I can write a transaction API, and then I can call that particular function, chain code function from the outside, and then if that transaction is valid, then I will get the response back. Similar way SDKs are there. So SDKs are nothing but the software development kit, which help you out to connect two systems. Okay, so if you are like in the Java SDKs are there, in Android SDK, iOS SDKs, right? So SDKs are nothing but the predefined or pre-written libraries or packages which help the developer to write their own functions, okay, to connect two systems. So basically with the help of SDK, we can write the middleware in the Hyperledger Fabric. Okay, so whenever, let's say, any request is coming from your Android application, the format which network understand, or the Hyperledger Fabric network understand, if your request is not coming in that format, then your transaction cannot be processed, right? So SDK will make sure that whatever request is coming from the client, that is your Android or your Angular client, so that request should be converted into the networking form, the Fabric network format. Okay, so that the next job can be done. So basically in the Fabric, so whenever we store the data in the Hyperledger Fabric ledger, so the data will be stored in a byte format. Okay, so that is the format which generally we use. So this SDKs will take care in whatever format you get the data, so they will take care. Okay, the data should go inside in the proper format. Okay, and then last comes as a CLI. So the another way is you can interact with the network with the CLI also. Okay, so CLI meaning like just your terminal. Okay, so from your terminal also you can put some command, you can run some command, and then you can interact with the network. Okay, let's say if you want to do some transactions, so you can interact with the you can put the command on the terminal, and then you can interact, you can do the transaction from the CLI also. So initially we'll start with the CLI only. So in our practicals, when we run our first network, that time we'll start with the CLI only. Okay, and then slowly we'll move to the SDK part, how you can use the SDK and then APIs also. Okay, so this is the reference architecture of the Hyperledger Fabric. This is how the complete component of the Fabric will look like. Okay,
right. No questions as such. Architecture is quite clear, right, guys?
Okay.
Any questions from your end, Anirudh?
No, sir.
Okay, perfect.
Okay.
So now let's talk about the some features, so like kind of core features which Hyperledger Fabric provides. So the very first thing, highly modular and permissioned architecture. So you can see here modular, how it is modular. any component which you see. Okay, so let's say you want to change the consensus mechanism. Okay, so you can change the consensus mechanism. If you want to change the membership service provider, okay, like you don't want to use the Fabric CA, you want to use some third party certificate provider or the certificate authority, so that you can do, right? Then if you want to have the you don't want to write the chain code in the Golang, okay, you want to write in some another language like say Java or JavaScript, okay, so you have that also, like you can write the chain code in a multiple languages, right? If you compare with the Ethereum, you have the you have to learn the Solidity, you have to use the proof of stake only, right? So keeping those limitation in the mind, in the Fabric you have your choice, what kind of language you want to use, what kind of architecture you want to use, what kind of consensus algorithm you want to use, and uh, how you want to use the certificate authority, okay, which type of which from which company, so everything you can decide. That is why it is highly modular, okay, like all these component you can plug in and play, okay. So that is the main feature, or that core feature. That is why right now companies are modifying or customizing the Fabric network as per their requirements, okay? And that is possible only because it is a highly modular architecture, okay. Then plug and play consensus that we have discussed, like any consensus algorithm, if you want to develop and use that, you can use in the Hyperledger Fabric network. But by default from the Hyperledger Fabric, you will get the Raft consensus algorithm, okay. So we will have one session on Raft consensus algorithm, how Raft works internally. So that session will be there, but it by default the Raft will be coming from the Hyperledger Fabric, okay. Then we have the low latency of finality or confirmation. So in the Bitcoin, if you see, in every 10 minutes your transaction will be confirmed when your block will be created. But here you can create a block minimum of 2 seconds or 1 second, okay. So in every 1 second or every 2 seconds you can create a new block, okay. So that kind of low latency right now we are having. Another modular thing or another concept we have is we can change the block creation time, okay. In the Bitcoin, if 10 minutes are there, then for decade, like the 10 minutes will be going on, right? You cannot do any change in the architecture. In the Hyperledger Fabric, you can change, let's say you want like I want only 100 transaction in a block, okay, not more than 100. So you can put that limit. Or if you, let's say if you want only 10 transaction in a block, so you can put that limit in your your block limit. Also, let's say you want in only 3 seconds one block should be created, okay. So that kind of change you can do, okay. Or if you want to decide like my block size should be 100 KB only, okay. It should not exceed more than 100 KBs. So that is also possible. So these kind of architecture change, okay, this kind of configuration change you can do with the Hyperledger Fabric, which is like a very difficult to find out in any other framework. Mostly it is not available, because these kind of changes are like a you are touching the core architecture, right? So that is why like a and it is not like like once you decide, let's say you have created a network, and in that network you have decided, okay, every 2 seconds one block will be created. So it is not like throughout the life that configuration will be there. In between, let's say 100 blocks have been created. After that, there is a requirement change from the business, like you should create a new block in every 2 seconds. Okay, earlier it was 3 seconds. Now it should be created in a 2 seconds. So that change you can do in a running network. Okay. So once you perform the change, then from that point, the new blocks will be there in every 2 seconds. Okay. So all these configuration change you can do on the fly, okay, in the running network, right? After that, the next core feature which it has is the queryable data, okay, rich queryable data. So it uses the cows DB, okay. So cows DB supports the rich queries, like just like in SQL, right? You have the you can write some select queries and you can get the data from multiple sources, like multiple tables, right? With the using of foreign key and all. So here also, if you want to do a rich queries, you can do that. So basically JSON queries can be performed, can be written in the Hyperledger Fabric database or in the ledger. This feature is very difficult to find in other blockchain frameworks.
Yeah.
So and that is why like the performance also, because performance depends on the query power only, right? How fast you can query the data. So your performance will be dependent on that. So here, since it supports the rich queries, like let's say you, so there also, like in Fabric also, you will be creating the data on the indexing. So let's say you have one collection that is student collection, or one collection employee collection. So if you want to get all the employees from the employee table, and where like where they have joined on particular year, okay, so you can put multiple arguments there, like a select from or get from employee table where the year is 2016 or 2017, like this. So you can get the filter data directly from the database or directly from the ledger. That kind of feature it has, and which provides a better performance in the system. Okay. Next, we have the multi-language smart contract support. As I said, it is not like you have to use a particular language only. Okay. So you can have, you can use the right now 3 languages are available: Go, Java, and JavaScript. In future, few more language will come, like a C# or Python. Okay, but right now 3 languages are available, but that is like in the industry, that is like no other blockchain framework will provide these many languages. Whether it will ask, okay, you can write your code, your smart contract in any language. Okay, it's like Ethereum, you can see, or Arthicoda, you can see only one language is there. Arthicoda is also JavaScript, but only one language, no multi-language support. Okay. Then flexible approach to data privacy. So flexible approach to data privacy, meaning you can restrict your data depending your on your privacy level. Okay, so first level you have channels, then second level you can have the private data collection, right? Then like these 2 major levels are there. Authentication, authorization is already there, which you can anyway use, but these are the internal labels with the channels and the private data. Okay, and which ensure that whatever data is you are going to share, that is need to know basis. So need to know basis meaning the person who is intended to see, only that person will see that data, or he should be knowing that data. Other will not be able to see any kind of data. Like it is not like if you are a part of organization, then all the members can see the data. But if you implement the private data, even though you are part of the organization, but you can, if you are not part of the private data, you cannot see the data. Okay, so that kind of privacy level we are having in the Hyperledger Fabric. Okay. Next, we have the flexible endorsement model. Okay, so in the endorsement model is also flexible. Like it is not like if you are putting a consensus algorithm, and for that consensus algorithm we have endorsing model or endorsing process. So in the endorsing process, what happens is minimum a few number of peers should endorse a particular transaction. Then only transaction will be valid. Okay, so it is not like that endorsement model is a fix. Like you have to get the, let's say, five endorsement from 5 peers. It is not like that. You can decide your number. Okay, like how many endorsement you need from the network, or from which organization you need the endorsement. Okay, let's say 5 organizations are there, and you need only endorsement from 3 organizations. Like if 3 organizations approve the transaction, my transaction should be valid. I should not wait for the all 5 organizations. Okay, so that is also achievable. That's also configurable. Okay, you can decide what kind of endorsement or how many endorsement you want for a particular transaction. So that is a flexible endorsement. In Ethereum or in Bitcoin, that is not possible. Okay, there is only one concept. You have to get the 51% majority, then only you will be creating a block or whatever mining process. Okay, so these are the features which Fabric provides, and that is why right now enterprise companies are using this framework. Okay, any questions here?
No, I think it's quite clear. About the couch database, so when we set up the Fabric, basically, so it get installed automatically, right?
Yeah, there is a provision. So by default, the level DB will come.
Okay.
But there is a provision to integrate couch DB also.
Okay.
Yeah. So by default, it will not come. Like if you start the network, initially it will not come. But if you want to integrate, so there is a minor change which you have to do. If you do that change, then your couch DB will be integrated.
Okay.
Yeah. So moving on, next thing which we have is the network components. Okay, so let's talk about the network components here. So the very first component we have the peer node. Okay, so what are the peers in the Hyperledger Fabric? So peers are the fundamental elements, or you can say main elements in the network. Okay, in the Bitcoin, if you see, you will have the nodes, right? Different types of nodes: main node, lighter nodes, or mining nodes, right? So here the peer nodes are the very fundamental elements. Okay, on the peers only our complete network will be running. Okay, so the hierarchy, if you understand or if you visualize, first we are going to have the organizations. Okay, so organizations are the visual thing, or the virtual things. Okay, organizations are the virtual, like org1 is there, org2, org3, like multiple organizations you have, and that is physically nothing you will see like this is my organization. Okay, so on the server or on the network, you will physically, or you will see the peers. So inside your organization, your peers will come. Okay, so let's say you have created one organization. That organization, you name it as a org1, and org1 you have 2 peers, peer 1 and peer 2. Okay, so for peer 1 and peer 2, you physically you can see, okay, 2 containers are running that are from the organization 1. Okay, so virtually they will be part of organization 1 in the configuration, but organization physically will not see anything. Okay, you will see peers only. That is why we call it a fundamental elements. Okay, because ultimately the thing which, like, on a particular component, if you do anything, that is a peer. Okay, second thing is they are the actual instance who will be hosting the ledger. Okay, so whenever you create a Hyperledger Fabric network and you do the transactions, those transactions will be stored in the ledger, and ledger will be hosted by peers only. Okay, so peers are the one who will be hosting your ledger. Okay, also they will host the chain code. Okay, so both chain code and the ledger will be hosted by peers only. Okay, in the diagram you can see I have 3 peers, P1, P2, P3, and on the peers you will find chain code as well as the ledger. So S1 is the chain code and L1 is the ledger. Okay. So every peer will have the same copy of chain code as well as same copy of ledger. Okay, so all P1, P2, P3 all are having the S1 only, and all are having L1 only, right? So then in one peer you can have multiple ledgers as well as multiple chain code. Okay, so a single peer can have multiple ledger also, it can install multiple chain code also. Okay, so it has the capability to run multiple things. Then a single peer cannot be owned by multiple organizations. That is very important. Okay, if you create a peer, that peer will be can be part of only one organization. Okay, it cannot be part of multiple organizations. Okay, then whenever you connect with the application, okay, or whenever you connect with the network, okay, from your client application, it will always be connected to peers also. Okay, so that connection will happen between your front end client to the peer. Okay, so that is the very first connection. Like let's say if you want to do a transaction, so you have to do that transaction. So the very first request will come to a peer only. Okay, it can be come from to org1 peer or org2 peer, anything which you mention in the configuration. Okay, but the request will always come to the peer only for any kind of transactions. Okay, so that is all about the peers. So the very key point to remember here is these are the fundamental elements, and they are the one which will be hosting your ledger as well as the chain code. You can install multiple chain codes on the peer. You can have multiple ledgers on the peer. Okay, and one single peer cannot be part of multiple organizations. Okay, this key point always remember, because when we go in the next topics, the complex one, don't confuse with this concept. Okay, when we, let's say when I say multiple channels, multiple chain codes, don't confuse with this, like a one peer cannot be part of multiple organizations. Okay, that is for sure.
Yeah.
Then moving on, now let's understand type of peers.
Sorry to interrupt.
Yep.
I have a question. Are chain code and smart contracts similar? Like chain code is like we can execute code there, and right, and smart contracts the same thing is happening. So are they similar?
If you see in the Ethereum, yeah, of course they are similar, but in the Hyperledger Fabric, a bit minor difference is there. So basically, in the Hyperledger Fabric, we can write the contract. So in the contract, what we write is we write our logic. Okay, so we can write multiple contracts in the Hyperledger Fabric. Okay, in let's say I have a vehicle, basically a vehicle type of chain code I'm writing. So I can write multiple contract, one contract for a bicycle, one contract for car, one contract for truck, right? So multiple contracts are there. Now, when you deploy your code to the network, that time all your contracts will be packaged in one package file. That package file we are going to deploy on the network. That is your chain code. So basically, in a very simple term, chain code is a collection of contracts. Okay. And that collection can have one contract also or multiple contracts.
Multiple contracts.
Okay.
Yeah.
So that is a minor difference we have. So when you write the chain code, when you write the code, that you will be writing in a contract. When you deploy the code, you will be deploying as a chain code package.
I have one question.
Yep.
I heard that we can deploy only one time our smart contract. Sim that applicable for chain code also?
No, you can deploy multiple times. Only difference is like you have to, let's say, first time you have deployed, and next time you have some changes also, right?
Okay.
Let's say the first version you have there only 5 functions, you have written 5 function logic. Now requirement change, you have to write 6 additional one. Okay, so with that you can upgrade your chain code, same chain code with a different version. Let's say first version was 1.0, now you can deploy the next one with 1.1. Okay, that is upgrade process.
Okay. And another question is, CowDB is a NoSQL database or a SQL database?
It is NoSQL database. It is just you can say brother of MongoDB.
Yeah.
Thank you.
Okay.
So JSON based structure would be there. Like
Yes, document based database.
Database. Yeah.
Yes. So maybe in future we'll find some additional one. Maybe MongoDB support will come, but right now only CouchDB is there.
Mm-hmm.
Okay.
Yeah.
Any other question?
No.
No.
Okay. So now we have seen the peer node. Okay. Now in the peer node also we have types. Okay. It is not like all the peers which you see in the network, those are less like a same. Okay. They are also having the types, and according to types, their functionalities or their features will be different. Okay. So the very first type is leader peer. Okay. So what is the first thing is why we need a leader peer? Okay. So the very first question is, if you see in the private blockchain, okay, so the very first thing is the performance. Okay. So like we should have the highest performance in the network. Okay. So how we can improve the performance when we have the less interaction or less communication between the components. Okay, let's say one person is there, okay, and he is doing one job, correct? Now he's doing his job, but in every 5 minutes one new disturbance is coming, or new some people are coming one by one, and they are asking for something from that person. Okay, so the job which he is doing already, that job will be impacted, right? Because multiple people are coming in every 5 minutes or every 2 minutes, and they are disturbing him, right? So of course his performance will be degraded, correct?
Mm-hmm.
In the distributed network also the same concept applies. If one node is running, okay, and he's doing his job, he's doing something, and if other nodes are again like one by one coming and disturbing him, asking for information or making a connection, then it will degrade his performance, right? Same thing happened here also. So as we know, we have two types of nodes. One is peer node and the orderer node. Okay, so peer node are like who are the hosting the ledger, or who are the hosting the chain code. Okay, there is a ordering node. So in the Bitcoin and the Ethereum, you must have seen mining nodes who mine the block and like who generally create the block, correct? Here also in the Hyperledger Fabric, we don't have mining nodes, but we have ordering nodes, basically ordering service. Okay, so the job of ordering service or ordering node is to create a block and distribute that block to the peers. Okay, now if my orderer is busy in the creating a block, okay, and if multiple peers are coming, because every peer needs new block, whenever a new block is created, multiple peers will need that, correct? So if multiple peers are making a connection between orderer, because orderer is one only, okay, one or max you have 2 3, and if multiple, let's say you have 100 peer nodes, and if they are communicating with the orderer again and again and again, then it will degrade the performance of the orderer, and he will not create the blocks on time, right? So to avoid these kind of things, we have a type of peer, that is leader peer. So from every organization, one peer will be there. He will be a leader peer. Okay, his job is to get the new block from the order. Okay, whenever a new block create, let's say in a one organization you have 10 peers. Okay, so out of 10 peers, one peer will decide this is the leader peer. Okay, and only this leader peer will be allowed to communicate with the order. Other 9 will not be connect to the order. Okay, so now if you see, we have just minimized the communication between peer and order to we have just minimized 9 times. Okay, only one time, only one peer will communicate with the order. So likewise, if you have 10 organizations and every organization has 10 peers, so earlier 100 connection were being stabilized. Now only 10 connection will be there, right? So of course, when 100 connection and 10 connection, you can see the difference, right? So always like your order will be running in a very smooth, it will be running smoothly and it will be doing his job very fast, correct? So this is the main job of the leader peer. So leader, every organization will have a leader peer. That leader will be getting the new blocks from the order, and then he will broadcast that block to its organization's peer. Let's say nine other peers are there, right? So then he will distribute, he will broadcast those new blocks and new transaction to other 9 peers. Okay.
So if there is any need to update the ledger, okay,
of course.
So even the consensus will be made by all the peers, not just by the leader peers, right?
Yes. So see, what happens is there is a procedure. So when a new block will be created, when the consensus has been established, everything is finalized, then new block will be created, right?
Correct.
So the leader peer will get that new block, and then that block will be broadcasted to other peers for the same organization. Okay, so that they can also do their verification. So at the time of commitment, so this process, like committing or adding a new block to the ledger, that process we call it the committing process. Basically, commitment is happening. So in that committing process also there is a verification process. Okay, so every peer will have their verification process. They will check it out. Like if I am on the block number 9, so next block it should be block number 10, right? It cannot be block number 11. So they will just check it out. What is the block number which is coming from the leader peer? Okay, whether it is right or not. Okay, leader will check it out. What is the block number I'm getting from the order? I am getting a correct block number or not. Okay, so these kind of validation will happen. So that validation will see in detail what kind of validations are there. But on generally these kind of validation will be there. Like what is the block number? Who has created that block? How many transactions are there? Then who has signed those transactions? Then who has provided the endorsement for those transactions? So these kind of validation will be happening on every committing peer. Okay, all 9 or plus leader peer, all 10 peers, they will do this job of validation. Okay, so basically here the concept is leader peer. What is the job of leader? It will receive the new blocks from the order, and then it will again broadcast that block data to the organization's peer. Okay, in the same organization. Okay, so if organization A is there or org1 is there, so org1 leader peer will broadcast the transactions and the block to org1 peers only. Okay, it cannot broadcast to the org2 peer. Okay, clear?
Yeah.
Then the next concept is the anchor peer. Okay, so first type was leader peer, second was the anchor peer. Okay, these are the types. Now, what is the job of this anchor peer now? Okay, so in the Hyperledger Fabric, new blocks are coming. That is fine. Those blocks are distributed or committed to the peers and all ledger. All those things happens. That is the job of leader peer. Now, since we are in the distributed network, right? So no one is knowing about others, like, because everyone is in silos. They are part of single network, but all nodes are running in a separate environment, correct? So then how they will know about each other? Okay, so let's say 2 organizations are running, and in 2 organizations, how those organizations will get to know, or how the peers of those organizations will get to know about the next organization or the other organization. Okay, like basically they every peer will get to know like how many peers are there in the organization B, how many peers are alive, how many peers are in a stop condition, what is their current state, right? What is their current block number, what is their ledger state. So these kind of information, every peer will exchange with everyone, correct? To make sure that the network is in a sync. Okay. So if the peer-to-peer connection is not going to happen, then what will happen is some peers can be on a particular, let's say, all the peers are down in the organization B and no one is aware of that, right? That kind of thing can happen. So to avoid these kind of thing, we have a protocol. That protocol is gossip protocol. Okay, so in the gossip protocol, what happens is our peer-to-peer connection will be stabilized. Okay, so peers will connect with each other and they will share their they will exchange the information. What kind of information? Like what is the current state, like how many peers are alive in your organizations, right? Then what is your world state, what is your current block number, right? This kind of information they will share with each other. But again, the question here is, or the problem here is, if all the peers are connecting to each other. Okay, let's say our organization A has 10 peers, organization B has 10 peers. If all 20 are connecting to each other, then there will be a mess, right? Correct?
Yeah.
Whenever this kind of connection happens, there will be a mess, right? Because a performance also, because one peer is there, he is trying to connect with other 19, and likewise other second peer is also trying to connect with the other 19s, right? So that will create a mess. So to avoid that mess, what concept we have is the concept of anchor peer. So we can configure anchor peer organization wise. Okay, we'll say this is the anchor peer in our organization. If from the other organization, if someone wants to get the information about the first organization, so what he or she does is that peer should connect to the anchor peer of that organization. So let's say these are my peers in organization B, and if these two peers want to know about the first organization, okay, if they want to know, okay, what is their current state, what is their like block number, current block number. So what they will do is they will connect with this anchor peer. Okay, and this anchor peer will be connecting to next anchor peer in this organization. Okay, so A and B both are having one anchor peer. So this anchor peer will connect to each other. Not all the peers will connecting to each other. Only anchor peer will connect to each other. They will exchange the information that, okay, in my organization only one peer is alive. Anchor B, like only two peers alive, like myself and one another peer. Two are dead. Here the organization B anchor peer will say, okay, I am only one peer is alive, that is I am. Other two peers are in a stopped condition. Okay. So this information is running on a gossip protocol. So basically, in general way also, like in a human life, you must have heard the word gossip, right? So in gossiping, what we do is the information which I have, I will share with you. The information which you have, you will share with me, right? That we call as a gossip. So here also the same thing is happening. Whatever information this peer is having from organization B, he will share the information with this peer, and whatever this peer is having, he will share with this peer. Now, if this peer wants to know, okay, what is happening in organization B, so instead of going to the organization B, he will just do the gossiping with the peer, this peer, and he will get to know, okay, this is happening in organization B, right? So general gossiping, which happens in humans. So same thing is happening here also. Okay, but to avoid the complexity, only anchor peer will be doing that. So anchor peer will get to know about the second organization, and then other peers can get the information from anchor peer. Okay, and it is also configured per organization. So one anchor peer will be there in every organization, and that will be responsible for inter-organization communication. Okay.
Yeah.
So both are the different concepts, leader peer and the anchor peer. So you can understand the job of both the both type of peers. So a leader peer will receive the new blocks, and anchor peer will be responsible for inter-organization communication. Okay. The third one is the endorsing peer. So that will do tomorrow, or sorry, Monday, because endorsing peer has the complete endorsing process also. I have to explain you first endorsing process, then only you will understand what is endorsing peer. Okay.
Okay.
We'll stop here only till anchor peer, and then Monday we'll start with the endorsing peer.
Yeah. Sure.
Okay. So now, any questions?
Nothing as such, just to reconfirm the leader peer that we saw earlier. It is about to communicating with orderer. So only for communication purpose, leader peer will be able to avoid multiple connections.
Yeah. So whenever a new transactions and new blocks are being created, that will be coming from like orderer will send those or broadcast those to only leader peer.
Okay.
Then it's leader peer job to come again broadcast to the other peers in the same organization.
Okay.
Yeah. And one thing I forgot, the leader election here. Okay, so how we can set up the leader node? So we have two ways of doing this. One is static and dynamic. So static means as a system admin we can configure
explicitly
that
define.
Yeah. So this will be my leader peer. And if we put dynamic, then Fabric itself it will elect through an election process by all the peers. That is an internal process. So
can't we control that? Means what is the criteria for that election?
There is an internal criteria. Okay. Any peer can be leader peer in that process.
Okay. So it is Hyperledger which decides in dynamic.
Internal algorithm will decide. There is an algorithm which will decide who will be the leader peer. And generally we use dynamic only. The reason behind is, let's say you have defined a static one, and for some reason your leader peer is down. Okay. So in that situation, you have to keep an eye. Okay, my leader peer should not be down by any chance. Okay. So if leader peer is down, then that organization will be like it will not receive new blocks or new transactions, right? So to avoid that kind of thing, like first you have to make sure, like, okay, if my peer is like it will be running smoothly, it will not be getting down anytime, then that's fine. You can put static. But if you are putting dynamic, then you no need to worry. If that leader peer is down, again re-election will be happening within a second, and then your new leader will be there and he will be getting the transaction from the order. So by default, dynamic will be there, dynamic process, but static provision of static is there, which can be configured by us.
Okay.
Okay, fine then. So yeah, that's it.
Okay, thanks.
Yep, thanks everyone.
Thanks.
Have a nice day.
Have a nice day. Have a good weekend. Bye.
Bye.
Thank you.